I've been in networking for over a decade and decided to make some content to try to help others understand this industry. Let's talk about the relationship between an IP address and the subnet mask to see how an endpoint uses these two values to derive additional information about its network. So, an IP address and subnet mask can either be statically assigned to an endpoint or it can be dynamically learned by the endpoint. Then, once it has an IP address and a subnet mask assigned to it, it runs those values through an AND gate. And through that process, it's able to determine the network ID, the broadcast address, and any other local IP addresses. Basically, what are the usable address range for its local network? If you haven't really come across the AND gate, please check out the video on that if this isn't really a familiar process. So we're going to start with an IP address of 192.168.0.1. It's pretty common. You see that quite a bit in home networks. And we're going to give it a subnet mask, another very common one, of 255.255.255.0. Now, remember that these values are actually 32-bit values that we split up into these 8-bit sections called octets, and each octet is represented as a decimal number from 0 to 255. So to really understand what's happening here, we need to look at the binary, and we need to convert these addresses into the binary to compare the subnet mask and the IP address. If you're not real clear on how this works, please check out the video on binary. It kind of goes into the details of how this conversion happens. So this is the IP address of 192.168.0.1 converted into binary. Each one of those decimal numbers is represented by these 8 bits. And then the decimal point is kind of the break point between the bits there where the little spaces are. So this is the 32-bit representation of the IP address 192.168.0.1. Now we need to do the same thing with the subnet mask. So here, this one's a bit easier because we know that 8 bits in binary, if they're all ones, it equals 255 in decimal. And if you have a 0 in decimal there at that last octet, we're just going to have all zeros in the binary. This conversion is quite a bit easier. So the important part here is to remember that there are actually 8 bits between each one of these decimal points. So even though there's a 0 or like a 1 in the IP address, you still have to represent all the other leading bits to get to that 1 that's there. So that fourth octet in the IP address where it's just .1, we still have 7 zeros and then a 1 to represent all 8 bits of that octet. So next, the endpoint will do an AND process here. And at this point, we have to take each bit of the IP address and do an AND operation with the corresponding bit in the subnet mask. So the first bit of the IP address, we have a 1, and the first bit of the subnet mask is a 1. So we look at our truth table there, and if A and B are both equal to 1, then our output X is 1. So that is the result of the ANDing of the first bit of the IP address and the subnet mask. So now we move on to the next bit and we do the same thing. Again, we have a 1 in the IP address, a 1 in the subnet mask. We already looked at the truth table. So when you AND a 1 and 1 together, the output is a 1. So that's the next result. Now we're going to move on to the third bit here in that first octet. This is different. So in the IP address, it's a 0, and the subnet mask, it's a 1. So look at our truth table. When you have a 0 and a 1, the output is 0. So now we put that down. We continue this process for every single bit. We're not going to go through all 32 bits because I think that would bore all of us. So we're going to speed this up a little bit. So we can see that the rest of the first octet of the IP address is all zeros. And we can also see that the rest of the first octet in the subnet mask, they're all ones. Well, we just did that AND operation where you have a 0 and a 1 as the input and you get a 0 as the output. So we can go ahead and just put zeros for the rest of this. So that sped up the first octet. Now we look at the rest of these, and we're going to speed this up as well. So we can see that from the truth table that the only time that we get an output of 1 is when A and B are both 1. So every other combination is going to be a 0. When we look at the address and the subnet mask, there's only 3 places where we see that there's a 1 in the IP address and a 1 in the subnet mask that correspond. Those are the ones that are bolded here. We can go ahead and put in 1s as those results because we know that's going to be a 1 and a 1 for A and B, and the output is going to be a 1 for X. Everything else here is a combination of either a 0 and a 1 and a 0, or a 0 and a 0. So everything else is going to result in a 0. So our final result of ANDing the bits of the IP address and the subnet mask is right there. And that is known as the network ID. So the network ID, that basically identifies the network that the endpoint is part of. And any device that's on the same network will be able to come up with this same network ID when they do that AND operation of their own IP address and the subnet mask. So we need to convert this back into dotted decimal form, because if we were trying to communicate with somebody else, we wouldn't really want to have to read off our network ID as, 11000000101010001000, on and on. That would be insane. So converting it to decimal helps us be able to communicate this much easier. So if you're not sure about how to do this conversion, please check out the video on binary. Kind of goes into depth here, but we're going to go ahead and do this conversion quickly. And feel free to pause the video if you want to try it yourself and see if you get the right answer. So when we do the conversion from binary to decimal, our network ID should be 192.168.0.0. So that identifies the network that this endpoint with an IP address of 192.168.0.1 and a subnet mask of 255.255.255.0, that's the network that this endpoint is a part of. So now that we're done with the IP address here, we've wrapped up what we need to know about that for the moment. So we're going to shift things around to make room for some other operations here. Now, when we calculate the broadcast address and usable IPs, this requires us to examine the subnet mask in a bit more detail. There's a place here in the subnet mask where we change from being a sequence of 1s to be a sequence of 0s. That point is critical in interpreting the subnet mask. So every bit that's a 1 in the subnet mask is known as a network bit. And any bit that's a 0 is known as a host bit. And you'll see why in a moment here. But the network bits are used to determine which bits define the network or the network ID. And the host bits are used to address endpoints that are part of that network. And if we look at the truth table, we can kind of see how this might make sense, because we have to have an input of a 1 and a 1 in order to get an output of a 1. So when we look at our subnet mask and we have a string of 1s, whatever the value for those bits are in our network or IP address, they're going to translate down to a 1 because we have a 1 in the subnet mask. So we were putting a 1 and 1 together. So that's how we determine the network itself, that network ID. The host portion, since it's all 0s, that means one of our inputs into the AND gate is going to be a 0, which will ultimately result in a 0. You can't have a 0 input in an AND gate and get a 1 as an output. So anywhere where there's a host bit, when you're calculating that network ID and doing that AND operation, any host bit from the subnet mask is going to result in a 0 for that network ID. So when we look at the IP address that we started with, we can see this a little bit differently now. And we can see that the 1s from that IP address that we had, the 192.168.0.1, anywhere there's a 1 that was part of the network bits, those actually translated to a 1 for the network ID. The host bits there at the very end, that came across as a 0 in the final octet for the network ID because we were ANDing a 0 and a 1 together. So looking at this again, a little bit closer, the first 3 octets of the subnet mask, they're all ones. So that means anywhere there is a 1 in the first 3 octets of the IP address will also be a 1 for the network ID due to that ANDing operation. And then since the last octet in the subnet mask is all zeros, that means when we do that ANDing, that entire last octet is going to be zeros when we get that network ID. The network bits of the subnet mask are used to identify the network, and that is the network that the endpoint is a part of. So by definition, the network ID is the result of ANDing an IP address with a subnet mask. Another way of looking at this is to take an IP address and set the bits to 0 that align with the host bits of the subnet mask. Hopefully that makes sense. So when we look at that 192.168.0.1, anywhere where there's a host bit in the subnet mask, we just set those to 0 from that IP address, and that also gets us that network ID. So on the other hand, when we set all those host bits to 0, that gives us the network ID. But if we set all those host bits to a 1, so here we have another representation of, we have our network ID there, all those bits, those network bits, those are translated down. This last octet, we're going to set all those to a 1. And by definition, when all of the host bits are 1s, that is what gives us the broadcast address. So we already know that the first 3 octets are 192.168.0. And so when we look at this and we have 8 1s in the last octet, hopefully we're getting more familiar with this. If there's 8 1s in binary, that translates to 255 in decimal. So our broadcast address for this network is 192.168.0.255. So if you're not sure what a broadcast is, please review the video about communication types, and we kind of went into more detail about that. So the last thing we need to determine is what IP addresses are part of the same local network as our 192.168.0.1 endpoint. So after finding the network ID and broadcast, the usable address space is actually kind of easy to come up with because it's all the addresses that are between the network ID and the broadcast. So we know the network ID is 192.168.0.0. So the next IP after that would be 192.168.0.1. Well, this also happens to be the IP address that we assigned our imaginary endpoint for this example. So that's the first usable IP address of this network. Our broadcast address, that's when all the host bits are 1s. So to count 1 less than that, the bits would all be 1s except the very last bit would be a 0 because that's in the 1s place. So we subtract 1 from that, and here's what that would look like in binary. We have 7 1s and then a 0. If you're not sure how this conversion works, again, please review the binary on this, but that would result in 254 in decimal. So the last usable address in the range would be 192.168.0.254. So any address in between there is going to be part of the same local network. And what the endpoint knows is I can reach those endpoints directly at layer 3. I don't have to go through a default gateway. So now we're done. Now that we've done these calculations that the endpoint would do, we know how to determine the network ID, the broadcast address, and what other IP addresses are part of its same local network. These steps, they're the same steps no matter what the network is. Let me say it that way. In this example, it's kind of an easy one to look at, and this is a good place to start because when we look at the binary, you can see how the breaks happen on the octets. So in the subnet mask, where we flip from the 1s to the 0s happens right between the 3rd and the 4th octet. So it's very intuitive to kind of look at that and just separate that last octet off and know this is where hosts come from. The same process works though when we look at it in the binary, and it's important to understand the binary because when that transition from 1s to 0s happens at a different point that isn't right on this octet boundary, now we have to look at the individual bits to figure out what actually is the host bits. What is that a network ID, that broadcast address? It's not going to be a 255. We get other variations in there. And that can be kind of confusing for people if you don't understand the binary first. But that's what we're going to move to next is how do we calculate the same thing when it's not a clean break in the subnet mask on that octet boundary?